Hello, everyone. Okay, we're gonna get started today with our warm-up problem for today. Um, to get started, uh, in this particular problem, we have a car that is driving at 30 meters per second for 15 seconds, and it ends up being 100 meters north of their house. And we want to figure out, where did the car start? In general, and in this problem, you can assume that north is positive and south is negative. And a formula I can help you here is that displacement is equal to our velocity times time. So I think what we're going to do today for in terms of responses is we're going to do a poll instead of typing in your answers. We're going to do a poll instead with a few different answer choices here. If you aren't sure how to do it, there is a I don't know option for you. There's also a none of the above option if you feel like none of the above apply and you have a different answer. So it'll take a few minutes to work this out. Again, if a car travels at 30 meters per second for 15 seconds and it ends up 100 meters north of your home, where did the car start? You can assume north is positive and south is negative. Remember that displacement is velocity times time. Since we have 22 people, our goal today is let's get an 80% response rate. So I'm shooting for like what, 18 people, I think. We're shooting for a B today. Yep, we're at 54%. We're doing pretty well here. We'll take another 2 or 3 minutes to try to figure this out. If a car travels at 30 meters per second for 15 seconds and ends up 100 meters north of your home, where did the car start? You can assume that north is positive and south is negative. Just remember that displacement is velocity times time. Yeah, 13 out of 21. That's pretty good. That's pretty good. Can we get a few more? Oh, I don't think you're supposed to. Well, everyone is picking one answer. That is not the point. I think what happened, I didn't mean to share the responses yet. I think a lot of people just picked what other people are picking. That is not necessarily correct. It could be wrong. It could be right. I won't say. Uh, that's the problem with people just pick what other people are picking. Um, that's okay. That's okay. If you aren't sure, that's okay. You can always say, I don't know. And take another minute or two. We are at 17 out of 22. Our goal, we're shooting for a B today. Ooh, we hit a B. Okay, we're 81%. We have 4 people who haven't responded, but I'm pretty happy with where we are. If we can hit an A, ooh, we're at a B plus. We're at an A. Oh my God, I'm so excited. Right? We're at 21 out of 22. This is by far the best out of all of the 3 classes. I think 5th period hit 81%. And I think 4th period, we were stuck at a 70, I think. So 95 is really good. That means everyone in this class is going to end the semester with a 95. So I think you're all pretty happy because that's exactly how grades work. Okay, so what I'm gonna do now is I'm going to go over this problem here, and then we will see how you did it. In general, it seems like we have a lot of people decided to pick the second one, and but we will see if that's correct or not. We will see. So here is how we're gonna do this. I think the first step that helps the most for any problem is to first visualize the problem here. We're all visual learners. So first thing that helps is let's first identify what are we comparing all of our positions to. We want to start off with a reference point. So the reference point we're using this problem is we're comparing everything from home. So I'm going to be here. Okay, so this is our reference point, which means that x is equal to 0 here. This is because this is our reference point. And we know that we ended up 100 meters north. This marks the spot. And this is equal to 100 meters. Now, here's the thing. We ended up here. We did not start here and then go to here. We just ended here and we started from somewhere else. We need to figure out where we started off from. So here is how we're going to do this. The first thing we can do is let's model our position at any given point in time. So I want to know, okay, where am I at any given time, some given time? So in order to know where I am at any given point in time, what I need is I need a starting position, and then I need to know how far I've moved from that starting position. So if I want to know my position at any given point in time, what I need is a start, and then I also need to know how far I moved. Right. So in this particular problem, or if I want to know what my position is, I need to know where I started and how far I moved. Now, in this problem, we want to figure out where we started. So which means we need to figure out where was our final position, where we ended, and how far we moved during this. So our final position was 100 meters north. That's where we ended. You know what our final position is. We don't know where our start is. Well, we do know how far I moved, right? So how far we moved, we can also think of this as something we call displacement. And this is our velocity times time. So how far I moved? Well, we moved 30 meters per second for 15 seconds, which means we moved a total of 450. So we know that wherever we started, we went 450 meters north, and we ended at a final position of 100 meters north. So that means wherever we started, we had to have started at negative 350 meters or 350 meters south. So let's review this. I want to know what we can do is we can first say that if we want to show our position at any given point in time, what I can say is I want to know where we started off from and how far we moved from that starting point. So in this problem here, we don't know where we started. We do know where we ended though. We ended at 100, and we knew that we moved 450 meters during this time. So therefore, we had to have started from negative 250, and then we went 450 meters north, and then we added at a final position of 100 meters. Now, I can actually express this idea that my position is where I started off plus how far I moved in an actual equation. So this is something that you should write down in your notes somewhere. So what is my position? Well, in general, right, I can just say it's my position. I can just say that this is my x position. Okay, what I want to know is where my x is. or at any given point in time. Not those, not my my x's, but my x. Um, so my x position at any given point in time is my start plus how far I moved. So once again, when we talk about how far I moved, how far I moved is with my displacement, with my velocity versus time here. So I can just write this as v times t. And now, last but not least, we just need to express our starting position. So my starting position, I'm going to express this in terms of a variable x naught. This is a subscript. Again, this does not mean x times 0. Subscript, it's like a little label for a variable. I know I've done this previously. I'm going to start doing it again because I think it's very important to understand what a subscript is. So a subscript, example, this x naught is not the same thing as x times 0. It's more of like it's like a name tag. This is like a name tag. So when you see a little like 0, it just means a name tag. And it's like a name tag. In this particular scenario, this name tag here is our starting position. This x naught, x0, x sub 0, x subscript 0, x0. This is our starting position. Our x is our final position. And then this term here is our velocity times time, which is how far we move. So if I want to know where my final position is, all what I need is my initial position plus how far I moved. And so we can call this equation x is equal to x sub 0 plus v times t. So this equation is very helpful in general in terms of us solving any particular velocity equation, especially word problems. Having a general setup, this general equation is going to be very helpful. So I would highly encourage you to write it down because it'll be very helpful. So we can actually use the equation to solve this problem again. So if I want to show you how to do it here, my final position in this problem, my x is 100. My initial position, which we don't know, plus my velocity times time, which is 30 times 15. So if we do this out, we get that our x naught is negative 350. So I think this is a very just straightforward way of just using an equation to solve this problem here. So if we just have a general setup, a general equation, if we know if you know maybe where you started, where you ended, or your velocity, or your time, you can figure out some other variables from there. So we'll be doing this a little bit more. Being able to use equations to solve problems is very helpful. So this is one equation that I would highly recommend you understand. You got an idea of your final position is your initial position plus your velocity times time. And that's how you can do this problem here, is understanding that my final position 100 is where I started. Okay, so does that make sense so far? Okay, so what we're going to do next is I'm going to start. I'm going to review a problem from Codenames Velocity. So the key for Codenames Velocity is posted on Canvas. Open that up right now. I'm also going to put a link in the chat so you can all see it. So here is the key to it. It'll be good for you to go over the key. I'm going to go over one specific problem. I'm going to go very into depth into it. There's going to be a lot of information. It's going to be a little bit of an information overload. Try to take as much notes as you can. I have this stream video of the class videoed, and so it'll be recorded. So if you want to go back in time to watch it, it's also recommended. There's going to be a lot of information. I would recommend you try to pay attention to the best of your ability. Take notes if you can. I'm going to go into as much depth as possible to really show you all the different nuances for everything. Because we're going to do an assignment today that's sort of a continuation of Codenames Velocity. And the way the assignment goes is going to be almost identical to what I'm about to do. So if you can pay attention here, get an idea of what I'm doing, you'll be in very good shape for the assignment later today. So that's what we're going to be doing. So to get started, what I'm first going to do is I'm only going to review one story, but I think the way I do it, I think will help you figure out, help you understand the rest of them. what I'm going to do is I'm going to go over story 7, I believe. So I'm going to go over story 7 here. Story 7, which is VII. I believe this matches table U. And it's the one that looks like with time and position. With something like 0, 0, 1, 30, 2, 60, 3, 0, 4, 60, and then 500. So it's the one that looks something like this. So what I'm going to do here is I'm going to go over how to do everything in this problem. Well, pretty much everything. Okay, so to start off with, the first thing we can do here is let's figure out our average velocity and our average speed. So how do we do that? So our velocity is our displacement over time. Right? So how much my position changes divided by time tells me on average how fast my position is changing. If I want to figure out my average velocity, so what I mean by average velocity, what I mean is my average velocity for the whole journey. This is something that is very confusing for a lot of people. There are velocities for individual sections. There's also a velocity for the whole thing. This is something I want to distinguish right now. What I'm doing right now is I'm figuring out the average velocity for the whole thing. If I want to figure out my average velocity for the whole thing, what I'm going to do is I'm going to look at my total displacement and my total time. So how do I figure my total displacement? Well, displacement is where I started. How far am I at the end relative to where I started? At the very end, my position is 120. At the very beginning, my position is 0. So my total displacement is 120. I don't care that I went forward and backwards and I did a bunch of, whatever. It doesn't matter. I only care about where I started and where I ended. And where I started is 0 and where I ended is 120. So my displacement was 120. How long did this occur? This occurred over 5 seconds. So my average velocity is my total displacement over my total time, which is 120 over 5, which is 24 meters per second. If I want to figure out my average speed, it's very similar. Speed is not displacement over time, it's distance over time. So if I want to figure out my average speed, well, it's similar, right? Well, here's the difference. The displacement, I only care about where I started and where it ended. For speed, I care about every single little detail about my journey the whole time. So the best way to think about this is let's just think about how far did I go every second. So if I started at 0 and I went to 30, how far did I go? I went 30 meters. When I go from 30 to 60, how far did I go? I went another 30 meters. So now I'm at 60 meters total. And I go from 60 meters back down to 0, I traveled another 60 meters, positive 60, not negative 60 for distance. Why? Because distance, I care about how far I physically travel. I do not care about where my position is. I care about how far I went. So I went 60 forwards and I went 60 backwards, but in terms of distance, all what I did was I just went 60 twice. So now my total distance travel is 120. I go another 60, so I'm now at 180, and then I go another 60, so now I should be at 240. So my total distance in this problem is 240. This occurs over 5 seconds as well, so my average speed is 48 meters per second. So what I'm going to do now is I'm now going to show what the graphs look like. The first thing I'm going to do is I'm going to draw the position versus time graph. So to draw a position versus time graph, you can literally just take our data points here, and I'm just going to fill it into this graph. 2, 3. Sure to start at 0, 0, and go to 130, 260, and go back down to 0, up to 60 again, and go. This is what my position versus time graph should look like. All what I did is just took the table, the points from the table, and I plotted it. And so that's a good way to double check, right? Is to see if you take the data points from the table and just plot it on a graph exactly, you can see the general shape of the graph. And this matches the graph, the answer key graph on the answer key, which I believe was graph I. Right? It looks pretty much identical. What I am going to do now is now I am going to show you how to calculate your velocity at any given point in the graph. So in your assignment today, what I will say is, hey, what is my velocity at 1 second? So what I'll ask is, what is my velocity at time is equal to 1 second? I guarantee you there'll be a question like this. Something like this. So I say, I want to figure out my velocity at time is equal to 1 second. So here is how I'll try to break it down in a way that hopefully this makes sense. So there are 3 sections in this graph, up, down, up again. Each one of these different sections has a different velocity. Why? Because our velocity is the slope of the graph, right? So this is one slope, this is another slope, and this is another slope. Now within each interval, what I call interval, as I call the points, the sections where the slope is the same. Within each interval, all of the data points in here have the exact same velocity because the slope is the same. So if at 1 second, at half a second, at 1.5 seconds, it all has the same velocity. So as long as I can figure out what my velocity is at any given point here, I know my velocity at time is equal to 1 second. So how do I figure out my velocity here? So what I want to figure out the slope at this point. What I want to figure out how far did I go in terms of position over how much time. So my velocity at time is equal to 1. What I want to know is how far did I go in that time. So what I can think of this as, okay, I traveled 30 meters, position change by 30 meters in 1 second. So this makes my velocity just 30 meters per second. Another way of doing the same thing is I can recognize that, hey, because the slope is the same for this whole section, I can also just say, instead of traveling 30 meters in 1 second, I actually traveled 60 meters in 2 seconds, and this also gives me the same velocity. So if I can either look at this whole section, or I can just look at this half section and actually get the same velocity. In terms of when you should do what, both of these technically will give the same answer, but I would recommend you use the method that has more clear data points, and you'll see what I mean with the assignment today. There'll be sometimes where certain sections of the graph where it's like you can't really sure if it's halfway or if it's 3/4. Use the part that looks the most clear to you. So in this particular example, both of them are pretty clear, so you can do either way. But the thing is, you want to recognize is that if I look at the slope of this whole thing versus the slope of it halfway, it's the same because the slope is the same, so the velocity is the same. So this one, finding your velocity at 1 second, is pretty straightforward, nothing crazy. What gets hard is when you start looking at the velocity at other sections of this graph. So for this first section, my velocity is 30 meters per second. Let's figure out my velocity for the second section. So what I'm looking at is my velocity at time is equal to, let's say, 2.5 seconds. So I'm going to do the same thing here. I need to figure out how much my position changed over how much my distance changed. How much my time changed. There's a lot of misconceptions here. I want to know is where did I start off at and where did I end? I started off at 60 and I ended at 0. So my position change is -60. What a lot of people might say is that, hey, I started at 0 at the very beginning and then I ended at 0. And so they're like, okay, that makes my velocity 0, or that makes my displacement 0. But the thing is, your average velocity between 0 and 3 seconds might be 0. But the velocity for this section is not 0. This is a very key distinction here. Your average velocity is you're looking at the whole thing. What we are looking at right now is we're looking at the velocity for any section. And so you want to be focused, zoomed in on one particular section when trying to find the velocity at a specific data point. And in this section here, I started at a +60 and I went down to 0. So my displacement is -60. And I did this over not 3 seconds, I did this over 1 second. Because I started going down at 2 seconds and I finished going down at 3 seconds. Another misconception is that a lot of people will say, hey, this whole thing took 3 seconds, or this whole thing took 2 seconds. But we really just want to look at how far did we go within the section. And in this section here, it only took me 1 second, and so my velocity here is negative 60 meters per second. And for the third one, let's say I want to find my velocity at time is equal to 4 seconds. Well, my total distance change was, my total position change was 120. This took 2 seconds. And so my final velocity is 60 meters per second. Okay. So that's how you figure out your velocity for the section. Your speed is going to be similar. I will also want to ask you, hey, what is my speed at any section here? What is my example? What is my speed at time is equal to 1? So there's different ways of doing this. You can also just look at what is my raw distance I traveled here. The simple way of just knowing this is that your speed is for any section. This is another distinction I want to make. Your average speed and your velocity, you will actually have to do these calculations separately. But for within the graph here, within any particular part of the graph, your speed is just your velocity, but always positive. So my speed here is also going to be 30. My speed here is going to be positive 60, not negative 60. And my speed here is going to be positive 60. And that's because speed, we don't care about direction. We only care about how fast you're going. And so we're literally just looking at the slope of this graph, but it's always positive. So that's what your speed should look like. And so it should be, you don't have to do a whole lot of calculations for that. Last but not least, I'm going to draw a velocity graph here. So in your velocity graph, you're going to be plotting your velocities similar to your position graph. So my velocity for the first, what I want to do is I want to plot my velocities for each section. Right? And once again, there are 3 sections in this graph. So my velocity graph should also have 3 sections. Between 0 and 2 seconds, my velocity is 30 meters per second. So I should have one section that looks like this at 32 seconds. Then I should have another section here. My velocity is negative 60. Note that these are not connected. Draw a little dotted line to show they're not connected. In this section only takes 1 second. And then last but not least, you have a last section which is positive 60. And so your velocity graph, as you can see here, there should be 3 sections here. And within each section, it's a horizontal line because your velocity is constant. And these are not continued because your velocity jumps. So here is what I mean by in terms of how to do this kind of stuff. If you look at the velocity graphs, on the answer key, it should match up with this. I try to go into as much depth as possible in terms of how to do this. So hopefully that gives you a strong foundation to work with here as we move on to the assignment for today. If you have any questions, let me know and I'll be happy to answer them. Otherwise, I will start. Y is t equal to 25 seconds this is 2.5 seconds. This is 2.5. Y is t. I'm just looking at the velocity at a particular point here. I just picked an arbitrary point. I could have picked 4.5. I could have picked 3.5. I could have picked 2.25. I just picked an arbitrary point here. But only thing that matters is the fact that your velocity within this interval between 2 and 3 seconds is going to be the same. So your velocity between t is less than 2 and less than 3 is going to be the same within this interval. I just picked the one that's betweenest, the one that's in the middle here. It doesn't really necessarily matter, but I'm just trying to show you a hypothetical problem where I say, hey, I want you to find the velocity at t is 2.5 seconds. This is what I mean by that. I'm just asking you to find a particular velocity at any particular point. The reason why I'm asking is that I want you to find the velocity for these different intervals. And within each interval, your velocity should be the same. Does that answer your question, hopefully? Okay. Okay, so here is what we are going to do today. So we're going to continue. There is a new assignment on campus called Codenames Velocity Part 2. It's sort of like an extension of this. It's sort of an extension of what we did at the end of last semester here. This time you're going to be looking at one graph and you're going to be analyzing the crap out of it. You're going to be analyzing every little detail of it and really try to understand every single section of the graph. There are a lot of questions on here. I admit there are a lot of questions on here, but once you get a feel for it, it should become quite straightforward. The due date I'm setting for this is next Thursday, Friday. So we'll have the rest of today and Tuesday to work on it. And so I'll answer any questions for it as well. Try to get started, try to do as much as you can. There are a few graphs on here that you will have to draw, but I don't think we'll get to that today. So get started on this. You can work as a group or as individually. I'll leave it up to you what you want to do. But other than that, I will send you off into your breakout rooms, and then let me know if you have any questions for me. Sorry, hello everyone. Starts 1:11. I miscounted time. Okay, so only homework is to try to get some of this done. I think we will see how deadlines go. I have this set for next Thursday and Friday, but depending on how everyone is feeling, I may be more flexible. We'll see how the pacing goes. So we'll see how it goes. See if you can do a little bit over the weekend, but don't stress yourself out too much for it. Other than that, have a nice weekend. A lot of shit's going on, so just do your best to hang in there. Let me know if you need anything. I have office hours again today from 2:40 to 3:40. So let me know if you want to come by and say hi or something. Other than that, I will see you all next Tuesday.